Hello and welcome to the Chemistry Academy. In this video we're going to go over section 1 of the 2022 National 5 Chemistry exam. If you're looking for help with section 2 then you can go and check out those questions in my other videos that you'll find on my National 5 Chemistry playlist. So if we get started with question 1, which of the following is the atomic number of a metal? So we've got the options of 1, 33, 45 and 86. So all we need to do here is look up the data booklet and see which of those atomic numbers is for a metal. We should find that 1 is not, 33 is not because it's on the right hand side of the staircase. 45 is in the transition metal block, so that is going to be our metal. So that gives us the answer C. Question 2, an atom is neutral because the number of positive protons is equal to the number of negative electrons. So what we're looking for here is answer B, the number of electrons equals the number of protons. Just be aware that if you're writing the reason for an atom being neutral in your exam, make sure you state the charges of the electrons and the protons and refer to them cancelling out. Although they've not done this in this question, they are pretty strict on that in the section 2, so if that is a question, make sure you say that the electrons are negative and the protons are positive. Question 3, when liquid water changes to steam. So what's happening here is some molecules are separating in order to change from a liquid to a gas, and in that instance what happens is that attractions between the molecules are broken, the intermolecular forces if you like, and those are usually much weaker than the bonds that are within the molecule. So what we're looking for is that weak forces of attraction between the molecules are broken. So it would be A. Because we don't, when we're melting or boiling covalent molecular substances, we don't break any attractions or bonds between the atoms, it's just attractions that are between the molecules. Question 4, which line in the table shows how the concentration of a solution changes when more solute or solvent is added? So the solute is what you put, so that's the stuff you're dissolving. So if you add more solute, your concentration is going to increase because you're putting in more of the stuff that you're dissolving. The solvent is where it went, that's the thing you're dissolving your substance in. So if you add more of that, you're going to decrease your concentration of your solute. So as you add the solute, the concentration will increase. As you add solvent, the concentration will decrease. Question 5, which of the following structures would be described as angular? So angular molecules are ones that look like water. They've got this kind of angled upside down V shape, if you like. And the only one here that is angular is B. A would be tetrahedral, it's got that 4 heads. As I like to call it, tetrahedral makes me think of 4 heads. And you can see here that this molecule has 4 heads around the central atom. C would be linear because it's in a straight line, and D is trigonal pyramidal. So these are the 4 shapes that you must know for your exam. So you've got tetrahedral at the top, angular here, linear, and then trigonal pyramidal. Question 6, electronegativity is a measure of the attraction a nucleus has for the shared pair of electrons in a covalent bond. When 2 nuclei that have different electronegativity values are bonded together, the bond formed is described as polar covalent. The bigger the difference in electronegativity values, the more polar the bond. The table contains electronegativity values for some atoms. Which of the following bonds would be the most polar? So this is a problem solving question. And this sentence here that I'm highlighting now is the key one. The bigger difference in the electronegativity values, the more polar the bond. You're asked to then identify which of those bonds is the most polar, so it's going to be the one where the atoms have the biggest difference in electronegativity. We can see that oxygen and hydrogen are the furthest away from each other. Oxygen's 3.4 and hydrogen's 2.2, so it's going to be the oxygen to hydrogen bond that's the most polar, so that's A. Question 7, which line in the table shows what would be observed during the electrolysis of copper chloride using a DC supply? So a DC supply is a direct current. That means that the electricity or electrons only flow in one direction, and that allows you to create a positive electrode and a negative electrode. so 2 oppositely charged electrodes. That then allows for separation of your ions. So if you've got copper chloride, you're going to have copper ions, which are always positive because they are metal. Normally you get copper 2 positive. And chloride ions we know are negative, Cl minus. So because our copper ions are positive, they're going to migrate to the negative electrode where they will become solid copper, because we don't ever know of copper being a gas, so it's going to have to be a solid. Then we've got chloride ions. They're going to go to the positive electrode because they are negatively charged, opposites attract, and they will end up forming chlorine gas because we don't really ever have chlorine as a solid. So at the negative electrode, we're going to have solid copper. At the positive electrode, we're going to have chlorine gas. So the answer will be A. Question 8, which of the following compounds is a salt? So there's a rhyme that can kind of help this. And it's bases, they're so great, oxides, hydroxides and carbonates. So anything that's an oxide, hydroxide or carbonate is a base. So that tells us that calcium oxide is a base and sodium hydroxide is a base, which means it whittles it down to the other 2 that are potentially salts. Now, hydrogen nitrate has the name ending that's a bit like a salt, because a lot of salts names end in ate. However, hydrogen nitrate is actually HNO3, and that is nitric acid if it's dissolved in water. So that is actually going to be technically classed as an acid or something that could dissolve to produce an acid, so that's not going to be our salt. Potassium ethanoate, that's got a metal and an ethanoate ion, which is what a salt is composed of, so that would be D. So the bases rhyme does help for the identifying a salt, or sometimes that question's identifying a base. So just remember, bases, they're so great, oxides, hydroxides and carbonates. So then question 9, the pH of the solution formed when ammonia is bubbled into water is most likely to be. So ammonia dissolves in water to produce an alkaline solution. You should have learned that in Unit 3 when you did the Haber process. So the only alkaline pH that's there is 9, and that is D. Okay, so you're looking for any pH really above 7 for ammonia when it's dissolved in water. Then we've got question 10. The apparatus shown can be used to identify the products of combustion. When gas X was burned, a colourless liquid collected in the cooled test tube, but there was no change in the lime water. Gas X could be. So because you've produced a colourless liquid in the ice bath, that means you've made water, but you've not changed the lime water, so it's not gone cloudy or anything, so it means you've not made carbon dioxide. So the only thing you've made is H2O. That means that your fuel most likely was hydrogen, because hydrogen will burn in the oxygen to produce the water. You can't have any of the other ones because all of the other options contain carbon, and there was no carbon dioxide made. So without any carbon atoms in your fuel, you can't make the carbon dioxide. Okay. If the lime water had turned cloudy, then it means that you'd produced carbon dioxide, and you actually wouldn't have been able to really tell which of the other 3 fuels that you'd burned. So question 11, which of the following compounds has the highest boiling point? You may wish to use the data booklet to help you. So here you're basically going to have to name these molecules and then look up their boiling points in the data booklet. So A is all single bonded carbons, so that's an alkane and it's got 4 carbons in it, which means it's butane. B is an alkene because it's got a double carbon to carbon bond. Again, it's got 4 carbons in it, so that would be bute, and specifically butanene. Sorry, my writing's not very good there. And then C has got a carboxyl group, which means it's a carboxylic acid. Again, it's got 4 carbons, so that would be butanoic. Oh, spell properly. Butanoic acid. And then lastly, D is an alcohol because it's got a hydroxyl group here, and it's again got 4 carbons, so that'd be a butanol, and it's specifically butan-2-ol because the hydroxyl's on carbon 2. So all we need to do is look up the boiling points for all of these in the data booklet. Now the boiling points are on page, this one here, page 9. Got some doodles on here already, I'll just rub them out. So we had butane, I'll just highlight them. So butane, the boiling point was -1, just make sure you look at the boiling points and not the melting points, because that is what we're asked about, the highest boiling point. With butane, then we've got but-1-ene, which is -6. We've then also got butan-2-ol, which is 100, and butanoic acid, which is 164. So that means that the butanoic acid has the highest boiling point. So that would be our answer, C. Question 12, which of the following molecules will decolorize bromine solution and also form an acidic solution when added to water? So if it's going to decolorize bromine solution, it needs to have a double carbon-to-carbon bond in it, so that rules out A and B. The double carbon to oxygen bonds don't decolorize bromine solution, that's a different functional group. So it has to have the double carbon-to-carbon bond if it's going to decolorize bromine solution. If it's going to form an acidic solution when you add it to water, it's probably going to have a carboxyl group. And we can see that D has a carboxyl group. C is an alcohol, can also be classed as alcohol because it's got a hydroxyl group, but that will not dissolve to give you an acidic solution. So our answer has to be D. Question 13, the first three members of the alkanones are... What is the general formula for these alkanones? So when you're suggesting general formula, the best thing to do is to write the molecular formula for the molecules you've been given as examples. So what I mean by that, if we just zoom in here, if we count on the first molecule, we've got 3 carbons, so that'd be C3H1234566O. Then the next one is C4H123456780, and then we've got C5 H12345678910O. All of the general formulas will start with the basis of CnH2n, and then we just need to see how or if we need to modify the numbers of hydrogens to fit. So if we take the first example where we've got C3, if we take the carbons being 3, then 2 times 3 is 6, so that matches what's there already. If we just check with the next one, the number of carbons is 4, we would need the hydrogens to be 8, which it is, so that matches. And then the last one, just to double check, we've got 5 and then 10. So that the CH part of those molecules fit CnH2n. They all have 1 extra oxygen, so we just add the extra oxygen on to the formula at the end. So that gives us answer B. 14, which of the following could be the formula mass of a cycloalkane? So cycloalkanes will usually, again, fit the formula CnH2n. They have the same general formula as the alkenes. So we're looking to see basically what cycloalkanes can maybe have the formula mass, one of those things given there. So if we're probably going to need at least 3 carbons because we start at like 40, and 3 carbons would give us 32. So we'll start off with 3 carbons. So if we have C3, it'll be H6. We'd then have C4, H8, and then C5, H10. So if we work out the masses of these, carbon has a relative atomic mass of 12. You can check the relative atomic masses in the data booklet on this big page here. So you can see carbon's relative atomic mass is 12. See, relative atomic mass. And hydrogen's relative atomic mass is 1. Normally by the time you get to the exam, people tend to know those ones off by heart. So 3 times 12 is 36, plus 6 is 42. So that's probably going to be our answer, but we'll just check C4. So 4 times 12 would be 48, plus 8 would be 56, and that's not an option. And then C5H10 is going to be too big. So B is our answer. Question 15, metallic bonding is a force of attraction between. So this is just a definition that you need to know, and it's positive ions surrounded by delocalized electrons. So that's answer A. A lot of people get confused here and think it's negative ions, but just remember the electrons that are delocalized and floating around, they're negative, so they're not going to be attracted to negative ions. So the ions in the metallic lattice structure need to be positive in order to keep those negative delocalized electrons circling around. Question 16, metals used to make aircraft have a density of less than 3 grams per centimetre cubed and have to withstand temperatures up to 600 degrees. Which line in the table gives the correct data for a metal used to make aircraft? So we're looking for a density that's less than 3 grams per centimetre cubed, which rules out C and D. And it needs to withstand temperatures up to 600 degrees. So the metal A that melts at 98 degrees is going to be no use because your plane would be a puddle. So we don't want that. So the answer must be B. Imagine that. I often wonder if people in the exams think about these things, like practicality wise, and actually picture a plane in a puddle. Anyway, bit of a tangent there. So question 17, which of these metals can only be extracted from its ore by electrolysis and forms an oxide that's insoluble in water? So the extraction methods, we can use the electrochemical series to help us. So anything that's above zinc needs to be extracted by electrolysis. So we've got from aluminium up to magnesium, all the way up to lithium. So copper and lead, they're extracted by heating with carbon, so it's not going to be one of them. Then to decide between aluminium and calcium, we need to look at what oxides they'll form if they're soluble. So then we need to use the insolubilities table. So if you're forming an oxide, it would be aluminium oxide and then calcium oxide. So we check the solubility of them. Aluminium oxide is insoluble, and calcium oxide is soluble. So the one with the insoluble oxide is going to be the aluminium, because calcium oxide is soluble. Question 18, which statement correctly describes the electron flow in the cell? You may wish to use the data booklet to help you. So firstly, the electrons in cells always go through the wires, never through the solution or anything else. They're calling the solution the electrolyte here, which is the technical term for the ionic solution that allows the conductivity of ions. But the electrons always go through the wires. They will then flow from the metal highest in the chemical series to the metal lowest in the chemical series. So if we look, we've got the options of aluminium and nickel. Aluminium is higher than nickel, which means the electrons will flow from aluminium to nickel through the wires. So it will be D. That's the answer. Question 19, which metal, when paired with magnesium in a cell, will produce the highest voltage? You must use the data booklet to help you. So again, the electrochemical series, their best friend here. Anything to do with metals generally is the electrochemical series that you would use to help you. And the highest voltage is between the metals that are furthest apart. So if we're looking to see which one is paired with magnesium to give a higher voltage, it would need to be the one furthest from magnesium. So if we look, magnesium's up here. The options we have are iron, lead, tin and zinc. So iron's here, lead's here, tin's here and zinc's up here. So it's lead that's the furthest away from magnesium. So that will be the one that gives you the highest voltage when you pair it with it. In question 20, we've got another electrochemical cell here. So the reactions occurring at each electrode are shown in the question. Which of the following equations is the overall redox reaction in the cell? You may wish to use the data booklet to help you. You don't really necessarily need to use the data booklet here because we were given the two ion electron half equations already. All we need to do is make sure the electrons can cancel out. We have 2 electrons in each equation, so they will cancel. We don't need to multiply any of them to make them fit. So when we cancel those out, we basically then just draw everything in a line together. So we'd have the Br2, I'm not going to write the state symbols here, SO3 2 minus, and then plus the H2O, going to 2Br minus plus SO4 2 minus plus 2H plus. So then you would just look through your answers and try and find the one that fits that. So it looks like it's going to be, yes, C. And you just want to make sure that the charges or the formulas of the ions are the correct way around, because sometimes they will put ones in that look like it could be the answer, but the formulas of some of the ions are a bit wrong. So that would be our answer there. Question 21, polymethyl methacrylate is a polymer used in the manufacture of craft windows. A section of the polymer chain is drawn below. The monomer used to make this polymer is. So my top tip for any questions on monomers being when you're given a section of a polymer is to every 2 carbons draw a squiggly line, because every 2 carbons is going to be 1 monomer's worth. when we're then looking to see what the monomer is, we have that section that's within that squiggly lines, and we just have to reform the double bond. So if we look at that molecule with the double bond reformed, we need the CH3 and the CO double bond OOCH3 bit on the same side, so that means our monomer is going to be A. They've been a bit sneaky here because they've drawn it as a mirror image. B looks like it's potentially the correct answer, but you'll notice there's not a CH3 group up there. So just watch out for things like that. Question 22, which line in the table is correct for the Ostwald process? So the Ostwald process is used to make nitric acid, so that's HNO3, and the catalyst is platinum. If you struggle to remember which way around the catalysts go for the Ostwald process and the Haber process, you can use the alphabet to help you. So Haber is iron, H and I are next to each other in the alphabet, and Ostwald is platinum, and O and P are next to each other in the alphabet. So question 23, radon-222 is a radioisotope present in the Earth's atmosphere. Plants can absorb radon-222 through their roots. Compared with radon-222 in the atmosphere, the half-life of radon-222 in the plant cells will be. So this is a bit of a trick question because half-life doesn't change unless you change the radioactive isotope that you have. So if you've still got radon-222, the half-life of it is going to be the same regardless of where it is, what temperature it's at, what pressure it's at. Nothing changes it. So it will be the same. Okay, 24. A radioisotope is used to monitor blood flow around the body. In order to prevent damage to the body, the radiation emitted must be able to escape through the skin. Which line in the table describes the type of radiation emitted and the half-life that would make a radioisotope suitable for this? So if it's going to have to penetrate through the skin, it needs to be beta, because alpha will be stopped by the skin. And we also always want, in anything to do with the body, medicine, whatever, the half-life to be short, so we're not prolonging any radioactive exposure to any patients. So that means the answer will be D. And then the last question. A student measured 25 centimetres cubed of sodium hydroxide for a titration experiment using a 100 centimetre cubed measuring cylinder. Their teacher suggested that there was a more accurate piece of apparatus to measure this volume. Which piece of apparatus should the student have used to more accurately measure out the 25 centimetre cube volume of sodium hydroxide? So the best thing you can ever use to measure out the volume of a liquid is a pipette, but that's only if the pipette is of that exact value, which in this case it is, because you have a 25 centimetre cube pipette and you're trying to measure out 25 centimetre cubed of sodium hydroxide. If you don't have a pipette of that exact volume, the next best thing is a burette. And then after that, nothing else is really very accurate, so you better not to use it. Definitely never measure any volumes in a beaker or a conical flask. They're really just for holding liquids. And a measuring cylinder, I know you used it like all the way through first to third year, but that was more just because I think if you smash pipettes, it's a bit expensive. So yeah, always a pipette for measuring out volumes of solutions. And if you don't have a pipette of that exact value, then the next best thing is a burette. So that's us for that 2022 multiple choice section. So like I said, if you're looking for help now with the extended response section 2, then head to my National 5 Chemistry playlist and you'll find those videos there. But I hope you found this helpful. If you did, please give the video a like. Don't forget to subscribe, and I will see you again soon.